In April 2021, an experiment was held to prove that the next generation non-combustible FRP and non-combustible heat insulation would be effective in reinforcing rebar and protecting fuel tank.
今回の実験は鉄筋ですね。鉄筋にうちの商品を塗ったもの、この鉄筋が曲がらないかどうかっていう実験をしたいと思います。通常この鉄筋を使って前回やった時はこれが曲がりました。
Here is an image of the bent rebar. A model of a house was placed on top of the rebar mesh and set on fire. Here is the rebar after the experiment. Compared to the one in the front, which was unused in the experiment, we can see that it has bent significantly due to the effects of heat. The diameter of the rebar used in the experiment was 12 millimeters. The one in this experiment had much thinner diameter of 3.2. The wire is sandwiched between a 2.5 thick non-combustible next generation FRP to test its heat endurance. The one on top is the same 12mm rebar that was bent in the previous experiment, and the one underneath is the 3.2 wire used in this experiment, but processed with non-combustible next generation FRP. As the model of the house weighs 60 kilograms, the board made of processed rebar had slightly bent even before exposure to any heat. This is because the board is actually made of thin wire and not very strong to begin with. People tend to think that steel frame buildings are resistant to fire. However, they lose their strength when heated in about 500 degrees Celsius. It can bend, making them vulnerable to collapse. In this experiment, we poured kerosene repeatedly and created a fire situation that would unlikely happen in real life.
これフラッシュオーバーおおよそ1500度から2000度だと思います。燃やさないっていう実験と燃やそうとする実験では全く中身が違う。それをご理解いただければと思います。
The experiment was terminated 15 minutes after ignition. A mere 3.2mm wire was able to support a weight of 60 kilograms without bending wide, even under exposure to the fire. If an ordinary rebar were processed with eStream's products, we believe the building will be protected to a greater extent. eStream has demonstrated that oil cans can be put in a box made of non-combustible next generation FRP and non-combustible heat insulation and placed in a flame of more than 1000 degrees Celsius without being affected. The box we are using this time will be smaller than the previous one. By directly exposing the entire box to the blazing flame, we have created a more severe situation for the experiment.
でその中でうちの箱にこれ灯油が入ってます。これを入れて、それでこれをただ置くだけですね。置くだけで中の灯油が無事かどうかっていう実験です。
In the event of a fire in vehicles such as ships or cars, there is a danger of fire spreading to the petroleum in the fuel tank and causing an explosion. eStream's goal is to cover the fuel tank with non-combustible material to prevent its ignition.
もっといって蓋が上がりますかね。近づかない方がいいかもわからない。
3 minutes after ignition, the lid appears to have become slightly loose. Heat has entered through the gaps of the lid. The oil cans inside are in danger of exploding. However, the purpose of each dream's demonstration is to show you as it is, even including the aspects that failed. We have continued adding kerosene to make the situation more extreme. The experiment was ended after 10 minutes. No external damage was apparent of the can inside the box.
中に入ってますか？
手は触れる。
触りますか？
ここはダメだけど。
見たらこれ大丈夫です。
The interior of the box was at a touchable temperature. The kerosene-filled can could even be held with bare hands, and its surface had stayed cool. The non-combustible next generation FRP has the property of sticking firmly to the material when heat is applied, so even if the lid floated a little, it seems to not have created a gap and prevented the heat from entering. We will also check the kerosene in the can.
今から熱伝導をお見せします。これ全然炎がありません。これ熱伝導って火事になるんです。
Even under circumstances where heat conduction alone is enough to cause massive fire, the oil can remain unchanged within the box made of non-combustible next generation FRP. Non-combustible next generation FRP is expected to be applied to fuel tanks and oil complexes. The heat adhesive nature of this material also prevents flames and smoke from entering, so it can be used to create non-combustible life-saving rooms. In this demonstration, we were able to show excellent results. To reduce CO2 emissions, there is a law of thought globally about how wood should be used in various scenes, such as building construction and theme parks. When it comes to fire resistance, heat resistance, and thermal conductivity, our non-combustible next generation FRP and non-combustible heat insulation materials is the one. You can now create things that was once deemed possible only in one's dreams. That is the idea behind each dream.